Welcome to Technical Insights. Today we are diving deep to the process of in-service vessel inspection and repair, as per API 510 and OSHA guidelines. Please watch the video till the end. It gives all information about vessel inspection and repair. In-service inspection and repair of pressure vessels are critical activities that ensure long-term safe operation in refineries, chemical plants and power industries. OSHA confined space entry rules put personnel during vessel entry, while API 510 provides the technical and procedural framework for inspecting, repairing, and re-rating vessels that are in service. Before any inspection or maintenance work is performed inside a pressure vessel, safety is the first and most important step. According to OSHA Standard 29 CFR 1910-146, any pressure vessel that requires human entry is classified as a permit-required confined space. This means a proper confined space entry permit must be issued before anyone goes inside the vessel. The permit includes all essential information such as the vessel identification number, the names of authorized entrants and attendants, the purpose of entry, date and time, atmospheric test results, and the method of communication and rescue. The vessel must be properly isolated from all energy sources. This involves complete depressurization, draining of process fluids, and purging with fresh air or inert gas. All inlet and outlet lines should be positively isolated by inserting blinds or spades, and lockout-tag-out must be applied on all valves and electrical switches. Before entry, the atmosphere inside the vessel should be tested. The oxygen level must be between 19.5 and 23.5%. There should be no flammable gases, and the lower explosive limit must be below 10%. Toxic gases such as hydrogen sulfide and carbon monoxide must be within safe limits. Continuous ventilation is required to keep fresh air circulating inside. All lighting equipment used inside must be explosion-proof and of low voltage. Every person entering must wear a safety harness, lifeline, and gas detector, and an attendant must always stay outside to monitor and communicate with the person inside. These steps ensure safe and compliant vessel entry according to OSHA confined space entry standards. Let's see inspection process according to API 10. The AP5 code governs the inspection, repair, alteration, and re-rating of pressure vessels that are already in service. It ensures that vessels continue to operate safely and without risk of failure. The inspection process under API 510 is generally divided into external inspection, internal inspection, and on-stream inspection. During external inspection, the focus is on the vessel's outer surface and attached components. Inspectors visually check for corrosion, paint deterioration, leakage, misalignment, settlement, and vibration. All visible defects such as cracks, coating damage, and insulation deterioration are recorded. Ultrasonic thickness measurements are taken on selected areas to monitor metal loss over time. Any difference from previous readings helps calculate the corrosion rate and remaining life. Safety devices like pressure gauges, safety relief valves, and nameplates are also examined to ensure they are in good working condition. Internal inspection is carried out when the vessel is opened, cleaned, and made safe for entry. Before performing an internal inspection, a pressure vessel must be thoroughly cored that all internal surfaces are clearly visible and free from deposits that could hide corrosion, cracks, or other defects. According to API 572, cleaning is a critical preparatory step that directly affects the accuracy of inspection results. In most cases, water washing or steam cleaning is carried out first to remove oil, dirt, and loose scale. Steam cleaning also helps in vaporizing hydrocarbons and decontaminating the vessel interior. If deposits such as rust, scale, or chemical residues remain, chemical cleaning is performed using suitable acid or alkaline solution selected to dissolve the deposits without attacking the base metal. After chemical treatment, the vessel is rinsed thoroughly and neutralized to prevent further corrosion. For heavy filing or hard coatings, mechanical cleaning methods such as scraping, wire brushing, or abrasive blasting are applied to expose the bare metal surface for inspection. Where oily or waxy residues are present, solvent or degreasing agents are used to remove them so that non-destructive tests, like dye penetrant or magnetic particle testing, can be conducted effectively. In special services where conventional methods are insufficient, techniques such as high-pressure hydro-blasting cleaning may be employed. The main objective of cleaning is to prepare a safe, clean, and accessible surface that allows inspectors to accurately evaluate the vessel's condition, measure wall thickness, and assess weld joints without interference from any contaminants or deposits. This inspection helps detect corrosion, pitting, cracks, or deposits inside the shell and heads. The inspector carefully examines weld joints, internal trays, baffles, and nozzles. For defect detection, various non-destructive testing methods are used. Ultrasonic testing measures the exact thickness of metal. Magnetic particle testing checks for surface and subsurface cracks on carbon steel. And dye penetrant testing is used for stainless steel or non-magnetic materials. If significant corrosion is found, the corrosion rate and remaining life are calculated using the formula based on previous and current thickness readings. Internal inspections are typically scheduled according to corrosion rates, but the maximum recommended interval should not exceed 10 years for carbon steel vessels. On-stream inspection is performed while the vessel remains in service and cannot be opened. In this case, ultrasonic thickness readings are taken at accessible points from the outside, and visual checks are carried out for leaks, vibration, or unusual sounds. Relief valve performance and calibration records are also verified to confirm system safety. Repair and alteration according to API 10 and ASME 2. If inspection re-damage or deterioration beyond acceptable limits, the vessel must be repaired in accordance with the API 510 and ASME 2. Before any repair begins, an API 510 certified inspector must review and approve the repair plan. Repairs may include weld buildup, replacement of corroded sections, installation of insert plates, overlaying of eroded surfaces, or the use of mechanical clamps and composite wraps as temporary solutions. All welding work must be done by qualified welders following approved welding procedure specifications. Non-destructive testing such as visual examination, magnetic particle, or dye penetrant testing is performed on each weld pass, followed by radiography or ultrasonic testing on the completed weld. If required by the code or material specification, post-weld heat treatment is performed to remove residual stresses. After completion, the repaired area may be subjected to a hydrostatic or pneumatic test to ensure the integrity of the vessel. All repair activities, inspection findings, and test results must be documented and retained in the vessel history file. In cases where the vessel is modified for higher or lower pressure or temperature ratings, or if the design is changed, this is considered an alteration. In such situations the vessel must be re-evaluated according to ASME Section V design calculations, and the re-rated data must be stamped on a new nameplate or re-rated plate after approval by the authorized inspector. Documentation and reporting after each inspection and repair activity. A detailed report is prepared in accordance with AFI Section 6.6. This report contains information about the type of inspection conducted, vessel identification details, inspection date, corrosion rates, thickness readings, damage mechanisms observed, and remaining life calculations. It also includes the results of non-destructive tests, photographs if available, and recommendations for repair or continued service. All records must be maintained as part of the vessel's permanent history to ensure traceability and compliance. The inspector also specifies the next due date for internal allowance based on corrosion rates and operating conditions. These reports are reviewed during audits, shutdowns, and future inspection planning.